that is additive inverse of any matrix A. So if A is Aij of order m cross n, so that additive inverse is what? Additive inverse is minus A. So if we have A, then additive inverse is minus A. That's it. So from here onwards, we start our class. So if we have the matrix A, then we can easily find the additive inverse of any matrix A. Done. Now we start the scalar multiplication of a matrix. Scalar multiplication of matrix. So suppose we have a given matrix Aij of order m cross n. Then Ka, where K is any real number, that is K into Aij of order m cross n. Means that element, that scalar quantity K multiplied with all Aij's. So we can say that K multiplied with all element of that given matrix. For example, suppose I am saying we have one matrix 1, 3, 5, minus 1, 2, 1. Then if we need to solve 2A, then that 2 multiplied with all the elements. So that is 2, 6, 10, minus 2, 4. Correct? So if we multiply a scalar quantity in a given matrix, then that scalar quantity multiplied with all element of given matrix. That is called 2A. Now here we can easily say, if I am saying that lambda 1A, that we can easily write lambda 1 into Aij of the same order m cross n. Now if the lambda multiply with two matrix A and B, so we can say lambda 1A plus minus also plus minus lambda 2B, where lambda 1 and lambda 2 are real numbers and A and B are same order matrix. Or that we know, if we are doing addition and subtraction, then matrix order must be same. Now if we multiply lambda 1 into lambda 2A, so this also we can write is lambda 1 into lambda 2A. Am I correct? So these are some results which we use in matrix multiplication. No need to worry much. We are covering that multiplication part from basics. So no need to worry much. We will cover all the questions based on JEE Main to JEE Advanced from here to here. Correct? And the multiplication in matrix, that is very important for JEE Main and JEE Advanced in both sections. So today we will cover multiplication of matrix. Now here for this we need to solve one question. Question is, A and B are two given matrix of same order. 3A minus B is 1513 and A plus 2B is 2 minus 1, 4, 9. Now you need to find A plus 4B. That you need to solve. So here very easy thing we have, that is B, that here we have B and 2B. So in the first matrix we multiply 2. That is 6A minus 2B. That is equals to 2, 5, 2, 6. Sorry, 2, 10. Now here we have A plus 2B. That we have is 2 minus 1, 4 and 9. Now easily we can add. If we add these two, then 7A is nothing but, last class we know, if we add two matrix, then correspond element added with correspond element. So that we can write is 4, 9, 6 and 15. Now we can divide by 7. So the matrix A easily we can write 4 by 7, 9 by 7, 6 by 7 and 15 by 7. Check. Now here we can observe 3, then here we have need 3. So that matrix multiplied with 3 and subtract. Now you can write 3A minus B is 1513 and 3A plus 6B is 6 minus 3, 12 and 27. Now we need to subtract. If we subtract this two, then we can say minus 7B is nothing but 1. Now when we are doing the subtraction, then correspond element subtract with correspond element. Now this minus we need to multiply. And after that, we need to simplify. So 1 minus 6 getting minus 5. 5 plus 3 getting 8. 1 minus 12 getting minus 11. And 3 minus 27 getting minus 20. So the B matrix we got divided by minus 7, that is 5 by 7, minus 8 by 7, 11 by 7 and 24 by 7. Check, everybody have the same answer of A and B or not?
Yes, sir, same answer.
Now you need to find A plus 4B. So what is A plus 4B? That 4 you need to multiply with all element with B. So A plus 4B is nothing but 4 by 7 plus 20 by 7, 9 by 7 minus 32 by 7, 6 by 7 plus 44 by 7, and 15 by 7 plus 96 by 7. So the exact answer we have is 1 by 7, 24, then 23 with a minus sign, 50 and 111. Check that answer is correct or not.
Yes, sir, correct.
So these type equation type question we have, then easily we can simplify that two variable setup and find the matrix. Now the best part, if A minus B and A plus B we are doing and getting the matrix of 2 cross 2, then A and B must be 2 cross 2 matrix. So we can find A and B wherever we need to use, we can. Check. Done. Good. After that, we need to start multiplication of two matrices. Multiplication of two matrices. So first, in this, we need to understand that can we multiply any two matrices of there, or there is certain condition. In this condition we can multiply, in that condition we can't. मतलब पहले हमें ये समझना पड़ेगा कि हम किसी भी दो मैट्रिक्स को मल्टीप्लाई कर सकते हैं, या मैट्रिक्स के मल्टीप्लिकेशन के लिए कोई एक पर्टिकुलर कंडीशन होनी चाहिए दो मैट्रिक्स के लिए, कि हम उन दो मैट्रिक्स को देख के बोल सके कि हाँ इन दोनों को हम मल्टीप्लाई कर सकते हैं, इन दोनों को हम मल्टीप्लाई नहीं कर सकते। तो उसका रूल बहुत सिंपल सा है। सपोज वी हैव अ मैट्रिक्स aij of order m cross n, and we have another matrix P of bij of order p cross q. A into B is defined only when जब जो पहले वाली मैट्रिक्स है, जो फर्स्ट मैट्रिक्स है, उसमें नंबर ऑफ कॉलम, और जो सेकेंड वाली मैट्रिक्स है उसमें नंबर ऑफ रो, ये दोनों इक्वल हो। क्या हो? इक्वल। तब हम कहेंगे कि मैट्रिक्स का मल्टीप्लिकेशन डिफाइन हो सकता है। सो व्हेन ए बी इज डिफाइंड ओनली व्हेन number of columns in A equal to number of rows in B. अगर दो मैट्रिक्स हमारे सामने ऐसी हैं जिसको हमें मल्टीप्लाई करना है, तो जो पहली मैट्रिक्स है उसमें नंबर ऑफ कॉलम और जो दूसरी मैट्रिक्स है उसमें नंबर ऑफ रो अगर सेम है, तो ये दोनों मैट्रिक्स मल्टीप्लाई हो सकते। अगर ये दोनों सेम नहीं है तो ये दो मैट्रिक्स कभी मल्टीप्लाई नहीं हो सकते। एनीवन हैव डाउट ऑन दिस? जैसे फॉर एग्जांपल मैं कहूं कि ए मैट्रिक्स है ए आई जे ऑफ ऑर्डर 3 क्रॉस 5, और बी मैट्रिक्स है बी आई जे ऑफ ऑर्डर 5 क्रॉस 2, सी मैट्रिक्स है सी आई जे ऑफ ऑर्डर 3 क्रॉस 4, और डी मैट्रिक्स है ऑफ ऑर्डर डी आई जे, that is 2 cross 3. Now, which of the following is defined? Which of the following is defined? First, AB, second, BC, third, CD, fourth, DA, fifth, CB, sixth, BD, seventh, AD. Now, which of the following is defined? So here what we need to check. If we need to check AB, then number of rows, number of column in A, number of rows in B, they are same. So AB is defined. Can everybody understand this? Now check BC. Number of column in B, number of rows in C. That is 2, that is 3, not equal.
सर
So,
ए बी और बी डी डिफाइन है?
BC डिफाइन नहीं है। CD डिफाइन है?
नहीं सर।
DA डिफाइन है?
नहीं सर।
सर डीए डिफाइन है।
चेक अगेन, DA डिफाइन है कि नहीं है? DA इज डिफाइंड।
सर डीए डिफाइन है।
DA
सर
defined
बीडी
because
डिफाइंड है।
number of column in D, number of rows in A, that are same. Again, क्या CB डिफाइन है?
नो सर।
नो सर।
वेरी गुड। क्या BD डिफाइन है?
यस सर।
क्या AD डिफाइन है?
नो सर।
नो सर।
AD डिफाइन क्यों नहीं है? बिकॉज नंबर ऑफ कॉलम इन A, नंबर ऑफ रोज इन B, they are not same. Anyone have doubt on this? So हम केवल वही मल्टीप्लिकेशन डिफाइन कर सकते हैं जिसमें नंबर ऑफ कॉलम इन फर्स्ट मैट्रिक्स is same as number of column in second matrix. Can anyone have doubt?
नो सर।
Very good. So मैट्रिक्स मल्टीप्लिकेशन करने से पहले हमें चेक करना पड़ेगा कि वो मल्टीप्लिकेशन डिफाइन है कि नहीं। डिफाइन होने की कंडीशन फर्स्ट मैट्रिक्स के कॉलम सेकेंड मैट्रिक्स के रो के बराबर होने चाहिए। अगर ऐसा है तो वो मल्टीप्लिकेशन डिफाइन है। एम आई करेक्ट? नाउ सपोज एक दूसरा क्वेश्चन हम फ्रेम करें matrix A, Aij of order M cross 3, and matrix B, Bij of order 2 cross P, and matrix C, Cij of order 3 cross 4. You need to find M and P if AB, if BC and CA is defined. Tell the answer quickly. Question is saying BC and CA is defined, then what the value of M and P? Yeah, good. Here the answer is M equal to 4 and P equal to 3. Can everybody get that? Everybody get that one? Easy. If I am saying BC is defined, then P equal to 3. Number of column in P same as number of rows in C. If I am saying CA is defined, then 4 is equals to M. Number of column in C is same as number of rows in. Am I correct? Anyone have doubt? Good. After that, here we have one condition. Easily we can understand when we can do the multiplication, when we can't. Now, what happened after the multiplication? Suppose I am saying matrix A, Aij of order M cross N, and matrix B, Bij of order N cross P. Now C is equals to AB. So we are saying that C is equals to Cij of order M cross P. So we are saying after multiplication, whatever the matrix we got, in that matrix, number of rows is same as A and number of column same as B. So the order of matrix after multiplication is M cross P. This N and N same. So the order is M cross P. Correct? Now, one more statement we can write that element Cij is sigma R equal to 1 to N Aik Bkj. This is the exact multiplication definition. We will explain it. No need to worry much. Up to here we can have when we can do the multiplication, that idea we have. After multiplication, what the order of that matrix, that idea we have. Now we need to understand what we are doing in multiplication, how we get this element. Am I correct? Now, suppose I ask that A matrix Aij of order 3 cross 2. We have another matrix Bij of order 2 cross 5. Now if C is AB, then order of C. Can anyone?
3 cross 5.
Very good. Order of C is nothing but 3 cross 5. That is M cross N. Am I correct? Good. Now, one more thing we need to understand. When we write AB, then we are saying A matrix A pre-multiplied with matrix B. Correct? Now, the same thing we can write that matrix B post multiplied with matrix A. Now that is the meaning of pre and post multiplication. So the same AB if you saw, then AB we can see with respect to A and B. So we are saying that A is pre-multiplied with B, or we can say that B is post-multiplied with A. So that is the meaning of pre and post multiplication. Here what we are here in this, what we are going to understand, the meaning of pre and post multiplication. So pre-multiplication means A multiplied with B, then AB. Post multiplication with B multiplied with A, that is AB. Can everybody understand what is the meaning of pre and post multiplication?
Yes, sir.
Very good. After that, we will start what is the meaning of this A, I, K, B, K, J. Correct? Now think. Suppose we have one matrix A, Aij of order 2 cross 2. We have another matrix B, Ij of order 2 cross 2. With the easy example, we understand. After that, we generalize things. So the A matrix we are writing A11, A12, A21, A2. Similarly, the B matrix we are writing B11, B12, B21, and B2. Now we can define the C matrix, that is AB. Now we are writing that element Cij and order is 2 cross 2. In multiplication, we know Cij is R equal to 1 to that 2 and A, I, R, B, R, J. Now we need to define that C matrix. C matrix is nothing but C11, C12, C21, and C2. Now what is C11? C11 is nothing but R equal to 1 to 2, A1R, BR1. Now write R. If we substitute R equal to 1, A11, B11. We substitute R equal to 2, A12, B21. Similarly, we define C12. This is nothing but R equal to 1 to 2, A1R, BR2. Now again, A11, if we substitute R equal to 1, B12 plus A12, B22. Again, if we define C21, that is nothing but R equal to 1 to 2, A2R, B1R, sorry, BR1. Now here if we substitute R equal to 1, so A21, B11 plus A22, B21. If we define C22, that is nothing but R equal to 1 to 2, A2R, BR2. Now substitute R equal to 1. So A21, B12 plus A22, B2. Can everybody understand what I am writing here? By substituting R, that's the general element. Now if we write these all elements in C, so if you observe that AB equal to C, now A matrix what we have? A11, A12, A21, and A2. What is the B matrix we are writing? B11, B12, B21 and B22. Now the matrix C we are writing after multiplication, that is C11, C12, C21 and C2. Now what is C11? A11, B11 plus A12, B2. Now what is C12? A11, can everybody able to see? What is C21? And what is C22? Can everybody able to see this? Now observe, when we are writing this, actually what we are doing, see, first element A11, A12, A11, A12. Now here we have B11, B21, B11, B21. So we are saying this element multiplied with this element multiplied with this, and addition. That is the first element. Am I correct? Am I correct? Now, if you observe this, A21, A22, that again multiplied with B11 and B21. Am I correct? So what we are thinking, for C11 and C21, what we are doing, A11, A12, A21, A22. Here we are multiplying B11 and B21. So just we take B11 and B21, that we are multiplying with this and add. That is first element. Now A11 multiplied with A21, B21 multiplied with A22 and add. That is second element in row. Get Utkarsh, Uttam and Karan. Similarly for C12 and C22. Check C12 and C22. So we have A11, A12, that multiplied with B21, B12 and B22. B12 and B22. Now this and this multiply and add. We can say again A11, A12, A21, A22, that we are multiplying with B12 and B2. Now multiply and add, that is C12. Now this A, B12 multiplied with this, B22 multiplied with this and add, that is C2. Now that's how we are doing the multiplication. So what's the process? If we multiply A and B, then for matrix B, take first column multiplied with the correspond row element and add. Now take the second column in B, multiplied the element in row correspond and add. That is matrix multiplication. Get how we do that multiplication? That the element Cij are equal to 1 to n AIR ERJ. That we are writing here. Yes. So that's how we are doing that multiplication. So when A and B multiply, if number of column in A same as number of column in B, after multiplication, what the order we have? M cross n. And in the multiplication, what the element Cij we are writing? That is R equal to 1 to n AIK into BKJ. AIK into BKJ means element, take element of first column in B, multiply all element in rows and add. Second column element in B, multiply all row element in A and add. Third column element in B, multiply with all element in row and add. Get the idea? Anyone have doubt? Now we will take the example. Suppose we are taking one matrix A, 1, 2, 3, 3, 1, 2. And we have another matrix B, that order is 2 cross 3. We have another matrix 1, 1, 3, minus 1, 2, 1. That matrix of order 3 cross 2. Now find AB and BA. First we start AB. Now we know in AB what we need to do. Take the element of first column in B, multiply element in row correspond and add. So what we are writing? 1 into 1 is 1. 1 into 2 is 2. 3 into 3 is 9. 1 into 3 is 3. 1 into 1 is 1. 3 into 2 is 6. Now take another column element in B and multiply in row and add. So minus 1 into 1 minus 1. 2 into 2 is 4. 3 into 1 is 3. Minus 1 into 3 is minus 3. 2 into 1 is 2. And what the answer for AB we have? 12, 6. What this element? 10 and 1. Check. Karan, Utkarsh and Uttam, you get that thing or not?
Yes, sir.
Now tell me what is BA. Anyone have any doubt? So that's how we are multiplying. That's how we are multiplying. Am I correct? Check.
Yes, sir.
Anyone have any doubt?
No, sir.
Done?
Yes, sir.
Now, generally we are saying that A and B are two given matrix. Then AB is not equal to BA. That easily we can judge also. That easily we can judge or not. See, here the AB matrix this, here the BA matrix is this. Both order are different, so how they cannot equal? So generally, if we have two matrices, then AB is not equal to BA. What happened if AB equal to BA? So we can say that A and B always not commutative. Correct? So what happened when AB equal to BA? See this. Whenever we have two matrix A and B and AB equal to BA, then matrix A and B said to be commutative matrix. That is commutative matrix. Write down this. If AB equal to BA, then we are saying that matrix is commutative. Now, second, if AB equal to minus BA, then matrix A and B said to be anti-commutative. Then matrix A and B we are saying is anti-commutative. So when the matrix is commutative, anyone? When AB equal to BA. And when the matrix is anti-commutative, when AB equal to minus BA. So if I am saying the two matrix is commutative, then AB equal to BA. If two matrices are anti-commutative, then AB equal to minus B. Can anyone have any doubt? Next thing we can say that A is a square matrix of order n cross n. A is a square matrix of order n cross n. Then A into I is I into A is equals to A. So if any matrix multiplied with same order identity matrix, then we have the same result, where I means identity matrix with order n cross n. So A into I and I into A into I and I into A is same. So if I multiplied with any matrix, then we have the same matrix. So if we observe A into I into A, so we can say AB is BA. So A and I are two commutative matrices, and that is very important statement. Then we can say A and I of same order commutative matrix. So if we have A and I with same order, then we can say these two matrices are always commutative. Anyone have doubt? So whenever we are dealing with A and identity matrix, these two matrices are always commutative. So we can say A, I, A, that is same as A. I with multiply with any matrix, then always we have the answer A. Anyone have doubt? Next result we are using A into O, that is O, where O is same order null matrix. So we are saying if null matrix multiplied with any given matrix, then we can have always a null matrix. So A into O is same as O. A into O is same as O. Done. Next, suppose we are saying A is any matrix Aij of order n cross n. And we have another matrix B that is a diagonal matrix with element A1, A2, A3 up to An in diagonal of order n cross n. The previous class we know this is the representation of diagonal element. In diagonal we have A1, A2, A3, An, and rest all elements are 0. Now we are saying what is AB? If we are doing AB, then this diagonal element A1 multiplied with all element in first column. Can everybody understand what I am trying to say? So this we have what? A11 into A1, A21 into A1 up to AN1 into A1. Similarly, that the second diagonal element multiplied with second column. Check. So this we can say A12 into A2, A22 into A2, and so on. A N2 into A2. Similarly, third element multiplied with, so A13 into A3, A23 into A3, and so on, AN3 into A3. So the last element AN multiplied with nth column of A. So A1n into AN, A2n into AN, and so on, ANN into. If we do AB, if we do BA, then what happens? If we do BA, then this A1 multiplied with all element in row. We can say A11 into A1, A12 into A1, A13 into A1, and so on, A1n into AN. Again, A21 into A2, the second element A2 multiplied in all rows element, A22 into A2, A23 into A2, and so on, A2n into A2. Similarly, that AN, if we multiply, that is multiply in nth row. So AN1 into AN, AN2 into AN, AN3 into AN, and so on, ANN into. Get that one? So if we pre-multiply of B, then diagonal element multiply in row. If we have post multiply, then diagonal element multiply in column. Get that one? That generalization we can write in post multiplication, diagonal element multiply in column, and in pre-multiplication, that diagonal element multiply in row. Get that idea or not? Now observe. If I ask a question, we have one matrix A, 1, 3, 2, 1, 1, minus 1, 2, 1, 2. And we have another matrix B, that is 3, 0, 0, 0, 1, 0, 0, 0, 2. Now tell me what is AB and what is BA. So if we multiply AB, then B is post multiply. So this diagonal element multiply in column. So the answer is 3, 3, 6, 3, 1, 1, 4, minus 2, 4. Here we are post multiplying, then diagonal element multiply in row. So here the answer is 3, 9, 6, 1, 1, minus 1, 4, 2. Can anyone have any doubt? Can anyone have any doubt?
No, sir.
Next thing, so here if we multiply a diagonal matrix, pre-multiply, diagonal matrix, pre-multiply a given matrix, then that diagonal element multiply in column. If we have post multiplication of diagonal matrix, then that diagonal element multiply in column. Am I correct? So directly we can write. Next question, I am saying if A is Aij of order n cross n and B is a diagonal matrix and AB equal to BA. Now observe. Here if we take any diagonal matrix and we are doing AB and BA, then AB is not equal to BA. Question is saying BA is a diagonal matrix multiplied with A and AB equal to BA. So we are saying these two matrices are commutative. Then B is always a scalar matrix. Then B is always a scalar matrix. Always remember this concept. That concept we use in a short form, in a short way to deal with the calculation. So if we are saying, why I am saying this, see, observe. If we multiply the diagonal element and we are saying these two elements are same, these two elements are same, these two elements are same. So we can say that A1 equal to A2 equal to A3 equal to AN. All elements are same in diagonal. That's why the matrix become scalar. So if we are dealing with a diagonal matrix, that matrix multiply with a given square matrix and AB equal to BA, then that diagonal matrix is always a scalar matrix. Scalar matrix means all diagonal elements are same. Scalar matrix means all diagonal elements are same. Am I correct? Now, again we can say A, B, C are three given matrix where matrix multiplication is defined. So we are taking order in such a way, any matrix multiplication of any pair is defined. So we are saying that we are taking order in such a way so we can multiply any two matrices. So here we can have some result. First one, A, B, C. That we can write is A have pre-multiplication with BC or C have post multiplication with A. So either we if we need to multiply three matrix ABC, so either we multiply AB, then multiply it with C, or we multiplying BC and A have pre-multiplication. So here we are saying with BC A have pre-multiplication or with AB C have post-multiplication. Next thing we can say that A into B plus minus C. This is same as AB plus minus AC. Now important, this result is very important. Why? If A is pre-multiplied with addition of B and C, subtraction of B and C, then AB and AC we are writing. Now in reverse, I am saying, suppose we have AB plus AC, then we can take that A matrix common only when A have same type multiplication with B and C. Now here A is pre-multiply, A is pre-multiply. So we can take A common with B plus C. Correct? Now if they write AB plus CA, that is not equal to A into B plus C, because here A is pre-multiply and here A is post-multiply. Am I correct? So we can take that A matrix common only when A is pre-multiplied with both B and C. Check, anyone have any doubt? Now, next thing we can write that A into lambda B, that is lambda AB, where lambda is any real. These are some properties which we are using in matrix multiplication. That is property segment 1. And we have so many these properties which we are using in matrix multiplication in different. Karan and Uttam, everything is okay? You get all these results? Here, one more result we can include in this. That result is saying this. If AB equal to AC, then we can say B equal to C if A is not a null matrix. If A is not a null matrix, then we can say AB equal to null matrix, or the best we can say A is not singular matrix. We will cover what is the meaning of singular and non-singular. If A is not a singular matrix, then B must be equal to C. Correct? Next thing, this. That result is also important, that we will use in so many places, so many ways. If A and B are square matrix of order n, then prove that A and B will commutative if and only if A minus lambda I and B minus lambda I is commute. Commute and commutative are the same thing. Correct? So the question is, A and B will commutate if A minus lambda I and B minus lambda I will commute. Or we can say in reverse also. If A and B is commute, then A minus lambda I and B minus lambda I is also commute. We know when two matrices A and B are commute. If A and B are commute, then we know AB is equals to BA. Can anyone have that doubt? No. Now, we need to check that A minus lambda I and B minus lambda I. This is same as B minus lambda I into A minus lambda I or not. Now check. Here we multiply then AB minus lambda A minus lambda B plus lambda square into I. Now this we can write is AB minus lambda B minus lambda A plus lambda square into I. Here we can write is, if we take if AB equal to BA, then in place of AB we can write is BA minus lambda B minus lambda A plus lambda square into I. If AB equal to BA, any A and B are commute. Now here we can take B common, then we have A minus lambda I. Now here we can have lambda I common, then A minus lambda I. So we can say B minus lambda I is same as A minus lambda I. Am I correct? So this result we can think in that way. If A and B are commute matrix, then this implies A minus lambda I and B minus lambda I is also commute. Commute means commutative of same order square matrix, where A and B and I are same order square matrix. A, B, I are same order square matrix. Correct? So if A and B are commute, then A minus lambda I and B minus lambda I is also computed. These results we will use when only we are dealing the result A and B. We have so many questions they asked in advance and mains where they didn't give numbers in the matrix. जहाँ वो numbers नहीं देंगे आपको, एक result दे देंगे A और B matrix में, उसी result की help से आपको calculation करना होगा. ऐसी सिचुएशन में इस तरह के जो रिजल्ट आज मैंने लिखे हैं मल्टीप्लिकेशन में, ये सब काम आते हैं. क्या यहाँ तक सबको सब कुछ समझ में आ रहा है?
Yes, sir.
Now here you need to solve AB and AC. A and B are two given matrix. This matrix have order 3 cross 3. This matrix have order 3 cross 4. And this matrix have order 3 cross 4. Now you need to find AB and AC. So here easily we can say that AC and AB is same. The answer for AC is also same. Correct? Now in this question, we need to find X. So just multiplication we need to do, no? First matrix have order 1 cross 3. This matrix have order 3 cross 3 and this matrix have order 3 cross 1. So just we need to multiply. So here we have ABC. So either we multiply BC, then A have pre-multiplication, or we have multiply AB, then C have post-multiplication. Then choice on your side. Correct? So tell me,
Sir, x is equal to root 48.
X is equals to root
48.
X square equal to 48 you get.
Yes, sir.
Then X is equals to plus minus root 48. No?
Okay, sir.
Plus minus root 48. We have two values of X, no?
Okay, sir.
Yeah. So here first we multiply in these two matrix. Then if we multiply these two, then we have order is 1 cross 3. So we have X minus 2. Then we have minus 10. Then we have minus 2x minus 5 minus 3 minus. And after that, this one we are multiplying with x41. And that we have is O of same order. So if we multiply this, then we have x square minus 2x minus 40 plus 2x minus 8. That is O. This matrix of order 1 cross 1. So here we get 0 of order 1 cross 1. We are saying x square equal to 48. Then x is equals to plus minus 4 root. Am I correct or not? Similarly, that second question, we need to show that this one is correct or not. So if I write what is RS and RT, what is RS? Cos S, sin S, minus sin S, cos S. And what is RT? Cos T, sin T, minus sin T, cos T. So if we multiply, then what we have? Check. First we take these two elements and multiply with the row and add. Then what we have? Cos S cos T minus sin S sin t. Then we have minus cos t sin S and minus sin t cos S. Then we will take these two elements sin t cos t and multiply and draw and add. Then we have cos S sin t plus sin S cos t. And after that minus sin S sin t and plus cos S cos t. Now we have the result for cos A plus B or cos A minus B. So this becomes cos of S plus t. This becomes sine of S plus t. This becomes minus sine of S plus t. And the last become cos of S plus t. And this is nothing but R of S plus t. So easily we can say Rs into Rt is R of S plus t. Am I correct or not? Am I correct? No. Now, this result we can generalize if we have this matrix. So we can say what the general result we are writing. If matrix A cos theta sin theta minus sin theta and cos theta, correct? Then A theta 1 into A theta 2 into A theta 3 and so on A theta n. That is nothing but A of theta 1 plus theta 2 plus theta 3 and so on theta n. That result we can generalize by observing this. Am I correct? So if A matrix is sin cos theta minus sin theta cos theta, then what is A theta 1, A theta 2 up to A theta n? This is nothing but A theta 1 plus theta 2 up to theta n. Can we get that? So this result we can generalize. Now, how we solve this type of question? Yeah, Utkarsh, can you solving this?
Yes, sir.
Now here what we need to observe. First we need to observe the X matrix order. So this matrix order is 3 cross 2, no? First. And
Yes,
you
sir.
are saying the X order is P cross Q. Now after multiplication you got 3 cross 3. So matrix multiplication is possible only when P equal to 2.
And
And
Q equal
after
to
the multiplication, you get the order 3 cross Q. That is 3 cross 3. So what the Q we have?
sir,
3.
Q equal to 3.
So X matrix is order. X matrix order 2 cross
Sir,
3.
2 cross 3.
So the X matrix you can assume A, B, C, D, E, F. Now only you need to solve A, B, C and D, E, F. And for that, multiply and compare.
Yes, sir.
Tell me the answer. That is A, B, C, D, E, F. Now you know how we do the multiplication. If we multiply, what we have? We have 2A minus D, A minus 3A plus 4D. Then we have B minus E, B, and 4E minus 3B. Then we have C minus F, C, and 4F minus 3C. And this matrix they gave what? -1, -8, -10, 1 minus 2 minus 5, 9, 22 and 15. Now we can compare. So A equal to 1, B equal to -2 and C equal to -5. If 2A minus D is -1, substitute A, then what is D? 3. Here we are saying that B minus E is -8, B is -2, then what is D? 6. Check. And we are saying C minus F is -10, then what is F? 15. Now you need to check that this result satisfying this or not. Correct? Now -3, -12, then E is 6, that is 24, and plus B is -2. See, that is satisfying or not? I think here we have one mistake. No, that is
Sir, F will be 0.
F will be 0.
Yes, sir. Sir,
Some
there is 2C
oh,
minus.
that is 2B minus E. Okay. And that is 2C. So that 2B. So this value, I think, that is -4. So what is E and F? Check, I did the calculation mistake. If we substitute -4 plus 8, then we have 4. And here if we substitute -10, then F0. Check. Now the answer is correct. Correct, no?
Yes, sir.
So what the X matrix we got?
Some
A, B, C, D, E, F. Am I correct answer?
1 second, sir. Minus. Yes, sir.
Good. Now solve the last question. This one. Then today's class matrix multiplication is done. After that, we will start. Next class is very important because in the next class, we will cover the A power n, how we multiply A and A and A again. This product is very important because they ask so many times A power n based questions. So we will cover that section in next class. Now we need to solve this. After that, we will bind up. That question you need to solve. If you have doubt, then next class I will discuss this. Correct? Just we need to do the multiplication these two and use the trigonometry identities result and check which option is correct. And after the class, I will share one assignment that you need to attempt. That assignment based on today's class concept and previous one. Okay.
Yes, sir.
Attempt
Okay, sir.
that questions. If any doubt you have, that we will discuss in next class. Next class is very important. Don't miss that. Okay.
Okay, sir.
Thank you.